This tutorial follows on the monster truck model where you added springs and dampers. Or open the monster_01.bin model. The next step is to add the correct joints at the correct positions in order to simulate motion. All the joints can be found under the Connections tab in the Tools ribbon. Here are tables showing what each joint constrains. This table can be found under Joints in Adam's Help. Each part has 6 degrees of freedom, thus a total of 120 degrees of freedom exists, and we want to constrain the model to only have 14. Translation and rotation for the whole model, along and about all 3 axes. Rotation for all the wheels and rotation for each suspension arm. Together it makes 14 degrees of freedom. Select the revolute joint to connect the wheel to the hub. Be sure that the directions of the joints are correct to ensure the desired motion. Hide the wheel's appearance to ease navigation of the model. Choose a spherical joint to connect the hub to the suspension arms. Create joints that look and move similar to the real joints as seen on the model. Redundant joints can be created. When all joints are created, we will check for redundant ones. Remember that you are working with rigid bodies. A model has redundant constraints if joints applied between bodies constrain the same degrees of freedom. Select a revolute joint to connect the suspension arms to the body. Ensure that the joints are rotated correctly for desired movement. This model is built with adjustable steering that can be formulated. Hook joints will be used to connect the hub to the steering arm. The hook joint will constrain rotation around the selected axis. The steering arms will be connected to the part steering with a spherical joint and steering will be fixed to the body. Steering can also be fitted to the body with a revolute joint and can be formulated to steer the car. Create all the same joints on the other front wheel. We will now add connections on the rear wheels and suspension of the model. Connect the wheel to the hub using a revolute joint. As you know, a revolute joint only allows rotation around a certain axis. Hide the wheels to ease navigation. Connect the hub to the bottom suspension arm using a revolute joint. This joint constrains the bottom suspension arm to only rotate around the local Z-axis, parallel to the global X. Connect the top suspension arm to the hub using a spherical joint. Hide the spring and damper to ease navigation and visibility. Create a revolute joint connecting the top suspension arm to the body at the location shown. Ensure correct rotation. I will now create a redundant joint, connecting the body and the bottom suspension arm with another revolute joint. This joint is redundant because the bottom suspension arm is already constrained only to rotate about an axis parallel to the global X. Create all the same joints on the other rear wheel, including the redundant revolute joint. Verifying your model also checks for redundant joints. To verify your model, right-click on the database icon and select the verifying tool. An information box will appear with the model details. As you can see, there are two redundant joints, joint 21 and joint 23. To fix this problem, we will replace the revolute joints between the hub and the bottom suspension arm with hook joints. Hide the wheels, go to joint 18 and delete the joint. Now, create a hook joint between the hub and the suspension arm. Choose an axis parallel to the hub and one parallel to the suspension arm. Check for redundant constraints. As you can see, only one redundant constraint remains. Do the same with the other rear wheel. No redundant constraints remain and the model now has 14 degrees of freedom. This concludes the constraints tutorial. This tutorial was proudly brought to you by STEC.